Amy Lee, an application engineer in the Precision System Business Unit at Texas Instruments. Today I'm going to show you how to do a precision current limiting for a supercapacitor application. So the challenge is sometimes you have an output current out of a regulator and you want to charge a supercapacitor of, let's say, 5 farad. In this case, you want to have some kind of circuit in order to monitor or to precisely current limit your application. So let's see how that works. So on the left-hand side of the board, we have a linear or switch regulator, and it will have some sort of output current in order to charge this supercapacitor of 5 farad. Let's say the supercapacitor can only handle a maximum current of 2.1 amp. So we want to give the output current, the charging current, a little bit off the 2.1 amp. So we will choose a 2 amp to charge the supercapacitor. In this case, we will have a circuit such as the LMP8646 in order to monitor the output current in order to make sure it never exceeds this 2.1 amp. So let's see how that works. So the I out will go through the R sense, creating a voltage drop across the input of the 8646, and that V sense multiplied by the gain set by the resistor RG will be equal to the output voltage of the LMP8646. And I've written out that equation here. So V out is equal to I out times R sense times gain. And for the LMP8646, the gain is just RG divided by 5,000. Now the V out will be connected to the feedback pin of your regulator. And let's say, assuming you're using an LM3102 regulator, that feedback pin will be 0.8 volts. So at any time that the V out exceeds this 0.8 volts, the LM3102 will decrease its output current in order to maintain a feedback pin of 0.8 volts always. So if you know that feedback pin is 0.8 volts and you know your I out of 2 amp and your R sense of 55 milliohm, and typically we want to choose an R sense in the milliohm range so you don't have a huge voltage drop across your load line. You can use this equation to calculate for the gain resistor RG. But the good news is you don't have to do this calculation by hand. We have an online tool that will do the calculation for you. So come on, let's take a look. You can go to the LMP8646 product folder, or you can look at the addresses at the bottom of your screen. So if you log on, what you will see is a configurable block diagram as I have shown you on the whiteboard. And you can click on each block in order to configure it. So you can choose your own I out, you can choose what kind of load you will need, you will choose what kind of feedback you will have, and the Webbench tool will be able to calculate the gain resistor for you as well as the output current error. And if you're feeling a little bit gung-ho, you can also go online to order the LMP8646 evaluation board. So what I've done is I've already probed the output voltage at the supercapacitor as well as the output current. And on the scope, what you will see is the output current in green plot at a steady 2 amp, never exceeding this 2.1 amp maximum. And the yellow line plot is the output voltage of the supercapacitor. So in summary, what I've told you today is how to do a precision current limiting for a supercapacitor application. In this case, we wanted to recommend the LMP8646 used to monitor or to precisely current limit your supercapacitor application. If you have any questions regarding what we talked about here today, particularly the LMP8646, go to the following web addresses. Thank you for watching.